Okay, so in this part of the video we're going to continue with our previous example, which is on the FSM1. So we've seen this already, so we're going to expand this. So last time we wrote the Verilog code using the 3-segment coding style, where we have a separate blocks or a separate part of the code for each main blocks. Okay, so we have the next state logic. Okay, so we have the code for the next state logic, we have the code for the state registers, and we have the code for the output logic. Now in this part we're going to try and combine the next state and the output logic together. Okay, so here we're going to combine. Okay, so we can simplify things, and it's a different style of coding. And notice that this is combinational. Okay, here is combinational, this one here is sequential, and here is combinational. So it's not a good idea to mix combinational and sequential. So combination and sequential should be written separately, but if we have combination we can combine them together. So we try and combine the next state and the output logic together. So let's quickly see how we can combine together. And as we can see here, for the next state logic, the inputs, okay, the input is A and Y. Okay, and for the output we have the input Y, small y, which is the present state. So here in fact you can make something like this. You can go always. Let's get our notes here. Okay. So let's see if we can combine these two together. Okay. Oops. Okay, so combine next state logic and output logic. Okay, gonna combine together. Okay, so always at E, small y, begin, case y. Okay. So let's look at back our ASF chart. So what happened if our present state is S0? Okay. What happened to the next state, and what happened to the output Z? So clearly you can see here, if our smooth this, so if our present state is S0, then we want Z equals to 1, right? So we can simply say Z equals to 1. Okay. At the same time, we also want to check that if A is equals to 1, then we have the big Y, the output of the next state logic, is equals to S1, else the big Y is equals to S0. Okay, so here we can see that if A is 1, then we are going to next state will be S1. Okay, if it's 0, then it's going to go back. Okay, and at the same time we are going to set our output Z. Okay. Okay, so we can continue with this. So Z equals to 0. Okay, here is Z equals to 0 in S1. If A Y equals to S3, else Y is equals to S2. Okay, so here I think it's basically the same as before. You can complete this yourself. What is the output and what is the next state, which is the big Y, right? Based on the present state Y. So here end case, and then we have the end, the always block. Okay, so this is called a 2-segment coding style, and I think you can see for yourself. There is a example here that they do the 2-segment coding style. Okay, so just like what I did there, so you set the output Z and then check the A. Okay, so another thing you want to try and do here is you want to try to simulate. okay, to the timing waveform. Okay, so let's see how this thing works. So if we have a clock, I think it's a big CLK. Okay, so let's define our clock signal just to understand this thing better. Okay, so and then we have our reset. Our reset is something like this. Okay, and then we have our input A. Okay, our input A is basically going to go 1 after 3 cycle. Okay, like that. 1 clock. Okay, something like that. Let's look at our block diagram and our code. So let's see the block diagram here. So you can see the input is clock, reset, and A, and we want to see what actually happened to our big Y, our small y, and our output Z. Okay. Now notice that this is combinational. Okay, so here I just say is combinational. Y is sequential, and here is also combinational. Okay, combinational means that the output does not depend on the clock and reset. Okay, and the clock is working on the positive edge of the clock. Oops, there. So, oops. Okay, so just identify where is your positive edge of the clock. Okay, so the positive is happening there. So remember that our small y will change value if it change value only on the green line. Okay, only on the positive edge of the clock, and the y and z does not depend on the clock. Okay, so let's look at the big Y first. So here we have our A and the small y. So let's look at the small y then. So the small y depends on the reset. So if we have a reset 0, let's say we say that the small y is 0 because the reset. Small y is 0, and then we can see that okay, at this edge of the clock the reset is 0. Then we can say that the y will go 0 all the way. Okay. Now let's look at the big Y. So the big Y depends on A and the small y. So the small y is there. Okay, so it depends on A and small y. So what is the value of A and small y? So here is 0. Okay, and here is also 0. So if both are 0, then what should be our big Y? Okay, so we can see our ASM chart again here. Okay, so 0 and 0. So we can see that the big Y is actually going to be okay. Here is actually S0 actually. Okay, so you can say S0. Okay, so because Y is 2 bit, so 0 0 is, remember 0 0 we set as S0. Okay. So the big Y is going to follow the combinational of A and Y. So basically here is also going to be 0, S0, I think there. Okay, and what about our Z? So also Z is going to look at here. Okay, so remember that this one is going to look at like this. Okay, and our Z is going to look at the small y. Okay, so if it's 0, our Z will be 1. Okay, you can see here. Okay, so here is Z equals to 1. Okay, so if small y is at 0, then our Z is equals to 1. Now, let's see what happened at this edge of the clock. So at this edge of the clock, what is going to happen is we have reset equals to 1, and here is going to transfer there. So what is the value there? the value there is S0, therefore this one will maintain S0. Okay, so it's going to put something like this. Okay, because remember in our code that we have this thing. Okay, so not reset, positive edge of the clock, then the small y is going to take the big Y at the edge of the clock. Okay, so then what happened to our big Y? So big Y, this one, if S0, and then we have A is equals to 1. Okay, so A equals to 1. So then we have Y, big Y equals to S1. So it's going to change to S1 right there. S1. Okay, and Z, okay, if it's S1, then okay, so Z is looking at the small y. So small y is at 0, then Z is going to maintain Vy. Okay, let's continue. So here, transfer here, S1. Now, S1 on the small y, A0. So let's see. S1 on the small y, and A0, S2. S2. Let's continue. So Z, S1, okay, so S0 is 0, S3 is also 0, okay. I mean y is not equals to S0, and y is not equals to S3, therefore Z will go 0. Okay, so we'll continue with this. Transfer S2. Okay, so now when S2, A is 1 and S2. So S2, A is 1, we take this guy, S3. Okay, S3, sorry, it's still S2. We are looking at small y, S2. Okay, transfer S3. Okay, now S3, A is 0, I'm going to take this guy, S3. So here is going to maintain on S3 there. Okay, so transfer, sorry, let's do this one first. So Z will be equals to 1 because now we have the S3 transferred there. Okay, so transfer S3 maintain. Okay, and then we have S3, A is 0. Okay, so S3, sorry. Okay, so we have so S3, the small y is S3. Okay, and then we have A is 0, so here is going to go, so here is actually going to go S0. Okay, here is going to go S0. Transfer S0 is going to go 1. Okay, S0 at 1 is going to go S1. Okay, so let's quickly check the solution down here. I think it should be correct. Okay, so S0, 1, 2, 3, and then back to 0. 1, 2, 3, and then okay, so 1 and S0. Let me just check here. So 1, so S3, I think something wrong here. Let's do this again. Put there. Okay, so this transfer S2. Okay, so when we are in S2, okay, and A is equals to 1, and therefore this one goes to S3. Okay, transfer S3. So when we're in S3, A is a 0, A is a 0, so it's going to maintain S3. Okay, S3 is 0, is going to maintain S3. Okay, so transfer, so this one also going to maintain S3, transfer. Now S3 and 1 going to S0. Okay, and here we are going to check S3 just like that. Okay, so I think that should be more correct. Okay, 0, 1, 2, 3 for 2 clock, and then back to 0, and then we have that, like so. Okay, so I think that's it. You need to know how to analyze the timing diagram. Okay, looking at the clock and which one is combinational, which one is sequential, and you need to understand actually how the flow actually works in the timing form. Okay, so I think that's it for this part of the video.